Hi students, next problem is example 19. There are 20 boys and 40 girls in a class. Half of the boys and half of the girls have brown eyes. Find the probability that a student chosen at random is a boy or a student with brown eyes. Okay, see there are totally 60 students in a class, 20 boys and 40 girls. Within that, half of the boys and half of the girls means half of the boys 10 students, half of the girls means 20. 10 boys and 20 girls have brown eyes. We have to find out the probability that a student chosen at random is a boy or a student with a brown eyes. Okay, so here the student is a boy or a student with brown eyes. These are the two events we have to consider. First event as a student is a boy. Second event is B, student has brown eyes. Okay, first find out probability of event A and event B. Total number of students is 60. First find out the favorable outcomes. For event A, student is a boy. Total number of boys is 20. Therefore, P of A equal to 20 by 60. Favorable means total number of boys 20. Total number of students is 60. 20 by 60 equal to 1 by 3. Next, a student has brown eyes. Okay, neither it is a boy or girl. So here 10 boys and 20 girls have brown eyes. See here number of students with brown eyes 10 boys and 20 girls, that is total 30 students have brown eyes. Therefore, P of B equal to 30 by 60, that is 1 by 2. Next, number of students who are boys and having brown eyes means it is A intersection B. A number is a boy and having a brown eyes. Okay, so here number of boys and having brown eyes is 10 members. Here number of students who are boys and having a brown eyes is 10. Therefore, P of A intersection B equal to 10 by 60 equal to 1 by 6. Next, so here we have to find out the probability of student chosen at random is a boy or a student with brown eyes, which means what? A or B. A or B. R means what? Addition, which means union. P of A union B equal to P of A plus P of B minus P of A intersection B. P of A is 1 by 3. P of B is 1 by 2 minus P of A intersection B is 1 by 6. We have to take LCM and simplify, then you will get 2 by 3. Okay. Next problem is example 20. Student A can solve 35% of the problems. Student B can answer 80% of the problem and student C can answer 50% of the problem. Find the probability that the problem is solved if they try independently. So here 3 students, student A, student B and student C. Okay. Student A can solve 35% of the problems and student B can solve 80% of the problems and student C can solve 50% of the problem. Okay, if you take individually or independently, what is the probability? Okay, so here consider the event. First event A solves the problem, B means B solve the problem, C means C solve the problem. A dash means what? That is complement of A. A means A solve the problem. A dash means opposite. A will not solve the problem. B means B solve the problem. B dash B will not solve. Similarly, C event is C solves the problem. C dash C will not solve. Okay, write down the probabilities. So here A. A will solve the problem is, what is the probability of first event? A. P of A, first student solve the 35%, means that is 35 by 100. P of A dash. P of A dash means that is 1 minus P of A. Okay. 1 minus 35 by 100. 100 is LCM. 100 minus 35. 100 minus 35 is 65 by 100. So therefore P of A dash is 65 by 100. Similarly P of B. Here B can solve 80% of the problem. Therefore P of B is 80 by 100. P of B dash equal to 1 minus P of B. 1 minus 80 by 100. 100 is LCM. 100 minus 80 is 20. 20 by 100. That is P of B dash. Next similarly C. C can solve 50% of the problem. Therefore P of C is 50 by 100. Similarly P of C dash is 50 by 100. See, the problem will be solved when at least any one of the student A, B, C solve the problem. See, there is one formula, P of at least one equal to 1 minus P of none. Here we can use this formula, P of at least one of them solving equal to 1 minus P of none. None of them solving. Okay, none of them solving means what? Not solving A, B not solve, C not solving. Okay, 1 minus A not solving means what? P of A dash, P of B dash, P of C dash. Substitute the values and simplify. We will get 187 by 200. Very, very important. Next, 21st problem. Two cards are drawn one after the other from a pack of 52 playing cards. Find the probability that they are both aces if the first card is replaced, not replaced. Okay, replacement problems. See, first one, two cards are drawn one after the other from a pack of 52 cards. We have to find out the probability of both aces if the first card is replaced. First consider with replacement. Okay, A with replacement. See here, totally 52 cards are there. First we have to find out the probability of getting a ace. In the first draw we are taking only one card at a time. Okay, probability of getting an ace. Total number of aces, there are 4 types of card. Okay, in each type we are having one ace. Totally 4 aces we have. Okay, therefore probability of getting ace in the first draw is 4 by 52. Here replaced. See, first we are drawing one card and replacing back to the pack of card. Then total number of cards remain same. Okay, the card is replaced before the second draw. Once again the card is drawn from the 52 cards. Again we have 4 aces in the 52 cards. Therefore probability of getting an ace in the second throw is also 4 by 52. Therefore probability of getting 2 aces means ace in the first draw and ace in the second draw, and means multiplication. 4 by 52 into 4 by 52 equal to 1 by 169. Similarly with replace, without replacement. Okay, see, probability of first draw is same, 4 by 52. Okay, see here first card is not replaced, then the total number of cards become 51. Okay, in out of 51 cards already one ace is drawn from the cards, pack of cards. Okay, see here when one card is not replaced there are totally 51 cards for the second draw. Since one ace is already drawn from the remaining 3 aces will be remained. Okay, we have to get 3 aces in the 51 cards. Therefore, the probability of getting ace in second draw is 3 by 51. Only 3 aces out of 51 cards. Therefore, probability of both aces equal to ace in first draw and ace in second draw. Ace in first draw is 4 by 52. Ace in second draw is 3 by 51. Okay. Next one. Example 22. A box contains 8 white chalks, 9 pink chalks. 2 chalks are taken at random from the box. Find the probability that both of them are pink. Condition is first one, the 2 chalks are taken out together. B. The chalks are taken one after the other without replacement. The chalks are taken out one after the other with replacement. See, first understand the problem. A box contains 8 white chalks and 9 pink chalks. Total number of chalks is 17. 9 plus 8 is 17. 2 chalks are taken at randomly from the bags. Okay. First find out the total probability. Okay. Both of them are pink. If the 2 chalks are taken out together. First consider A. 2 chalks are taken out together. See, total number of chalks is 17. Okay. Total possibilities means 2 chalks are taken at a time. Total possibilities is 17C2. Total outcomes. 2 chalks can be selected from 17. Therefore, it can be done in 17C2 ways. That is the total case. See here, the 2 chalks are taken out together. See, total how many pink chalks are there? Total 9 pink chalks are there. Therefore, number of choosing 2 pink chalks is 9C2. Total ways of choosing 2 pink chalks is 9C2. Therefore, P of both pink equal to 9C2 by 17C2. Okay. See, next one. The chalks are taken one after the other without replacement. Here, one chalk piece is drawn at a time. Okay. We are not selecting 2 chalk pieces at a time. We are selecting only one chalk at a time. The probability of first chalk is, see here, total number of chalks are 17. We are pink chalks. Total number of pink chalks is 9. Therefore, probability of first chalk is, we are selecting 9 pink chalks out of 17. Okay, possible outcomes is 9. Total outcomes is 17. Total number of pink chalks is 9. Total number of chalks is 17. We are selecting one pink chalk out of 17. Therefore, favorable outcome is 9. Total outcomes is 9. Therefore, probability of first chalk is 9 by 17 without replacing. Then the total number of chalks becomes 16. 1 less. Okay. Similarly, pink chalk is also 1 less. Therefore, probability of second chalk is 8 by 16. Therefore, P of both pink equal to 9 by 17 into 8 by 16 equal to 9 by 34. Next, with replacement. Probability of first chalk remains same. See, again that chalk is replaced. Then the total number of chalks remains same. Pink chalks also same. Then the probability of second chalk is also 9 by 17. Therefore, P of both pink equal to 9 by 17 into 9 by 17 equal to 81 by 289.